In this video, let us see about min term and max term. For any logic circuit, the input-output relationship can be given by a truth table. You see this circuit here, A and B are input variables and C is the output. So the truth table will give you the relationship between input variable and the output variable. For different combination of input, what will be the output? So the truth table is a unique method. That is, there is only one way to represent the variables in a truth table. For each combination of input, we will check what will be the output variable. In addition to truth table, we can also represent the input-output relationship using a Boolean expression. For example, for this circuit, we can write y is equal to AB plus CD. So instead of AND gate and OR gate, I can use some NAND gate or NOR gate or inverter, anything I can use and change the equation. So in such cases, there is a possibility to write the equation in many ways, or there is a possibility to reduce the equation or simplify the equation. Why do we need to simplify the Boolean expression? What is the advantage of simplifying is that we can reduce the number of gates here. So here 3 gates are used. If it is a bigger expression, you might have a more number of gates. So simplifying will reduce the number of gates. So if number of gates is reduced, cost will be reduced. And another thing, for the time taken for the gate to respond will be in nanosecond. So when the number of gates is less, your time delay for the response will be reduced. Let us take a 2-variable Boolean function. So 2 variables A and B are there. For example, let us take OR gate and its truth table. We can see here A and B are the input variables and C is the output. So that will be given by a truth table. Now you see the combinations of the input. For 2 variables, there are 4 combinations, 0, 0, 0, 1. That is, A can be 0 and B can be 0 and 1. Then if A is 1, B can be 0 and 1. So 4 combinations are here. So these 4 combinations, how it is here? So if A is 0, it is called A dash or A complement. And for here B is 0. So we can write this as B dash. So again here A dash, this is B and this is A and this is B dash. Here A and here B. So 4 combinations are available. That is, we are taking A as 1 and A dash as its complement. So it is 0. So the variables can appear either in normal form, that is like A or B. It complement form means A dash or A bar. So any notation can be used, because in some books they follow this dash, or you can put a bar also. Now let us take a 3-variable Boolean function. So 3 variables means A, B, C are there. How many combinations we will get? 8 combinations will be there. So let's see here, 1, 2, 3, 4. That is, for first 4 things, A is 0. And you have, we have already seen about 2 variable. So B, C here, 0, 0, 0, 1, 1, 0, 1, 1. Again, A will have 1. The same sequence will repeat here. Or you can remember this very easily. First take the least significant digit. So this one. Write 0, 1, 0, 1, 0, 1, 0, 1. Next 0, 0 2 times. 2 times 1, again 2 times 0, again 2 times 1. Here 4 times 0, 4 times 1. So you will get all the 8 combinations. So for 3 variable, you are getting 8 combination. It means that if there are n variables, you will get 2 power n combination. So in this case, 2 power 3 is 8. So if it is a 4 variable function, you will get 2 power 4, that is 16 combinations will be available. Next we'll come to the important topic minterm and maxterm. We have seen that for a 2 variable input there are 4 different combinations, a dash, b dash, a dash b, ab dash and ab. Here you can note one that have used a dot product. So both are same. Here if I place a dot or not, this is a product symbol. This dot product is also called AND operator. So if I combine these two input variables using this AND operator, I call it as a minterm. The same input variables, if I combine them using a plus operator or OR operator, we call it as a maxterm. For minterm, you should use a small m, and for maxterm use a capital M. Let us see about minterm first. So the two variables have 4 combinations and they are combined by this AND operator or dot product is there. So here 0 0, a dash b dash, a dash b, a b dash and a b. So 4 combinations for 2 variables. Now each of these combination we call it as minterm. So 4 minterms are here. So this minterm should be represented by a small m. So this is m0, m1, m2, m3. So how do you write it as 0? This is the decimal equivalent of this combination. 0 0 means it is 0. 0 1 means 1. 1 0 means it is 2. 1 1 means 3. So always start from 0. M0, M 1, 2, 3, 4. So it should always start from 0. Next, for 3 variables, how to write the minterm? Same procedure, but you will get 3 variables. So 8 combinations are there. So how to write this? Here you see A, B, C. All the 3 have 0. So it is A dash, B dash, C dash. So dot product because it is a minterm. So keep dot here. Here A dash, B dash, C alone is 1. So it is C. Next A dash, here B, then C dash. Here A dash, B, C. Here A is 1, remaining 2 are 0. So A, B dash, C dash. So similarly you can write for everything. And the last one all are 1, so it is A, B, C. So we have taken 3 variables with dot product, so it is a minterm. So all these are minterm. So minterm here always start from 0, 1, 2, 3, 4, 5, 6 and 7. So totally 8 will be there starting from 0 to 7. Now let us see how to write the Boolean expression from a truth table. So we know this is the OR gate and its truth table. But we always write C is equal to A plus B. How do you get this expression from this truth table? So we can use the minterms and derive this expression now. So this same OR gate truth table. So we know for OR gate 0 0 is 0, remaining will be 1. So this is A dash B dash, 0 1 means A dash B, A B dash, A B. So 4 set of combinations are there, and minterm also you can mark it 0 1 2 and 3. First, you have to identify the minterms which produce 1 in the output. Okay. So now we are going to write a expression from this. So first you identify the minterms which produce 1 in the output. So I can say M1, M2 and M3 are having 1 in the output. So this will not come as the output is 0. Then you OR those minterms. OR means put a plus sign. So take M1 plus M2 plus M3. So this is the output expression. Now instead of M1 I can write, what is this? A dash B plus A B dash plus AB. So substituting these variables instead of the terms. Now you simplify this one. So you see which is common here. A B dash, in these two terms A is common. So keep this one as such. Take A out, B dash plus B or B plus B dash. So what is B plus B dash, or what is 1 plus 0? Something plus its complement we are doing it. So it is nothing but 1. 1 plus 0 is 1. So we will get A dash B plus A. Now what, there is a absorption law which states that if you have A dash B plus A, it will be equal to A plus B. If you don't know the absorption law, you can still simplify it and get it A plus B. Okay. Using distributive law, you multiply this and then solve it, you will get A plus B. So C is equal to A plus B. So this is how you get the expression for OR gate using minterms. So this is called sum of minterms, because we are taking minterms and putting a plus sign in between. So we call it as a sum of minterms. Next we will see the max term. So when the two variables are combined with the OR operator, we call it as a max term. So here my OR term means plus symbol will be used. So here A plus B. See here A and B, both the values are 0. When it is 0, normally in minterm we take it as A dash B dash. But in max term we should take it as AB. Only for 1 we take the dash. See here A is 0, so A. For B, its value is 1, so I should write it as B dash. So here it is A dash plus B, and here it is A dash plus B dash. All these are called max term, and it can be represented by the capital letter M, M0, 1, 2, 3. This sequence remains the same. Next, for the same OR gate, let us write the output in terms of max term. Earlier, for the OR gate output expression derivation, we wrote the output in terms of minterm, that is sum of minterm. Thus, there we will find where is the output, where is the 1 in the output. But if you want to write in terms of max term, you have to find where is the 0 in the output, or we have to first identify max terms that produce 0 in the output. So in this case only 1 0 is there, and that is equal to M0. So C is equal to M0. Sometimes we may get two zeros, in such cases you have to AND those two max terms. So in this case we have C is equal to M naught. So what is M naught? A plus B. So C equal to A plus B. So this is the expression for OR gate. You might have noticed some similarity between the sum of minterm and product of max term. Surely there is a relation between these two. The same OR gate truth table I have taken. So when we wrote in terms of minterm and we wrote in terms of max term, what we get if we write in terms of minterm, C is equal to M1 plus M2 plus M3. When we wrote in terms of max term, C is equal to capital M naught. So what you can see here is that whatever number present here, so 1, 2, 3 is here, that is not present in the max term. So whatever it is here, it will not be available here. But both will give you the same output. It means that both are same. So capital M naught is equal to small m1, m2 and m3. Let us see another example, that is, let us derive an expression for AND gate using product of max term. So this is the AND gate and its truth table. We can write the max term here, M0, M1, M2 and M3. So first, to get the product of max term, we have to find where 0 is there in the output. So 3 zeros are here. So let us write C is equal to M0 dot M1 dot M2. That is, you are ANDing the max terms. What is this? A plus B. This is A plus B dash. This is A dash plus B and this is A dash plus B dash. Remember, while writing max term, 0 should be taken as A and 1 should be taken as A dash. So now C is equal to, what is M0? A plus B into M1 is A plus B dash, M2 is A dash plus B. So simplify this one. So if you simplify this one, just multiply first two terms, A into A plus A into B dash plus BA plus BB dash into the same third term. What is A into A? A into A is A. That is, 1 into 1 is always 1. If it is 0 into 0, also 0. So A into A is A. So instead of A into A, you can write A. Another thing here is B dot B dash is there. That is, A and its complement multiplication will always give you a 0. See here, 1 dot 0 will be always 0. So you can discard this term. So here A dot A becomes A, AB dash plus this I am writing as AB plus this term becomes 0 into this. Again multiply these terms with this one and simplify it, you will get A dot B. So this is the output expression for AND gate. So we have derived the output expression using product of max term. Let us summarize what we have seen for minterm and max term. For two variables, you will get 4 combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. If you write in terms of minterm, always 0 should be taken as a complemented 1 and 1 is a normal form. So it is A bar B bar. This one is A bar B, A B bar, AB, and small m is used to represent the minterm M0, M1, M2 and M3. For writing the max term for the same combination of input, 0 is the normal form and 1 will be the complemented form. So it is A plus B. Here operator is changed to plus. Here we have a product. And this will be A plus B bar. So we can write A bar plus B and A bar plus B bar. And here capital M should be used. To get the sum of minterms, first in the output table, you have to find the minterms which will give you 1 as output. Then or all those minterms, that is put a plus sign, you will get the sum of minterms. To get the product of max terms, first find max terms which produce an output 0. Then AND those max terms, that will give you the product of max terms. If you like the material, do subscribe to Read Electric Vehicle channel, and if you need any material or any queries to be addressed, you can mail to readelectricvehicle@gmail.com. Thank you.